but we're nowhere near. We don't see it yet, but we're nowhere near. We don't see it yet, but we're nowhere near.
Hey SMARS fans, how are you doing? Let me just turn myself down there so I don't hear a strange echo in the background while I'm talking. So, do you want to build some robots? Don't know where to start and don't know what you'll need or how to do it? Then you're in the right place watching the right video series. So we'll get right to it. If you stick around as well at the end of the show, I'm going to show you some interesting, exciting plans for my new studio as well, which is well underway. So, without further ado, I've got some exciting things to show him, like so excited to press these buttons as well, but I need to stick to my script. So, my name is Kevin. Come and learn with me as we build robots, bring them to life with code, and have a whole load of fun along the way. And this is what we'll end up with at the end of today's episode. So, let me jump into this. We have SMARS cam. I've got my soldering iron ready to go. We're going to do some live soldering. This is going to be exciting, possibly disastrous if I set my house on fire. But yeah, I'm sure it'll be a load of fun. So let me have a look and see if I can find the right button to press next, which is this one. So that's a nice little animation that I did with the, I have one of these gimbal things for my iPhone, DJI Mimo I think it's called, and it has like some free software that enables you to do little video things, and it has all the animations and transitions built in. So I thought I'd give that a bit of a go with when I was just doing some photos for Instagram. I usually take quite a few while I'm doing a build so that I can do them throughout the week and keep people interested in what I'm doing. So this week it's all about assembling our parts. So I've got a whole load, if I look over here on the table, we've got a whole load of different parts. We've got a whole load of track pieces there. We have our chassis, we've got a battery, we have some motors, we've got some bits of wire there. We've got our motor holders, we have some Arduinos, let's move him out of the way. We have a rangefinder, we have our motor shield and our rangefinder holder. I think that's all the parts that we need, and with some wheels of course. So some wheels just off camera here as well. And we also have some filament. So extra things that I have as well is some solder. My soldering iron is nice and hot. Hopefully you can hear me when I move away. I'm just aware that when I will need to move my microphone when I start speaking over there, because it's quite sensitive. I've got some flux as well. So I've got some flux, and I think that's it, just some tools as well. So I've got a little file that I use for preparing and cleaning up some of the parts. So let's get to the Keynote slide. So if I go to... nope. Find the right button, Kevin. It is that one, and then we want to share screen. Sorry about this. There we go. Share screen. Right. So week 3 is all about assembling the parts and doing a bit of soldering for the motors as well. So what we'll need is, what we'll cover off is cleaning up the 3D printed parts. So as you print them off the bed, sometimes they need a bit of cleanup required. So what I mean by that is some of the parts may, so these wheels, for example, the hole right through the centre of there, sometimes when you try and push the motor onto it, you don't get a good fit. And that's just to do with the sort of tolerances. If I push that, and it's quite a tight fit, that. So by using a tool such as a file, we can sort of make those parts fit much better. As well as that, things like the the chassis, sometimes that has sort of rough edges and things. So there's quite a few things we can do there from cleaning up. We're then going to assemble the parts step by step. We've got some wire to solder up the motors. So I've just measured that out as well, so we can talk through what's required there. We're going to solder the motors as well live and see how that goes, and we'll talk through some soldering technique as well that I've learned along the way. And we'll just attach the battery and the battery connector. I'm just looking around to see if I've got that to hand. If not, I've got a bag of bits underneath my desk that we can use as well. And then we'll attach things like the motor shield and the Arduino too. So what you'll need then, if you're building along for this week, you can see there on screen we've got the 3D printed parts themselves that we printed out last week. We have a battery connector, 250 RPM 6-volt motors. So if you're wondering what these are, how to get hold of them, what they're called, I just sort of hold that up there. You can see this tiny little motor. There we go. These things available most sort of places online. You can go to smarsfan.com. We've got a shop there you can buy them from. You can also buy them on Amazon. There's plenty of places. They're around about 8 to 10 UK pounds. So what's this? Probably about 8 to 10, 12 US dollars, that kind of price range. Which I always think is a bit expensive for what they are, but at the moment that's the price of them. I have seen them cheaper, and I think if you buy them in bulk, the price can come down a little bit too. You can get faster motors. I would say the 150 RPM is a good sweet spot to begin with. It's not too fast, and it's quite powerful as well. It can go over most surfaces. We want some red and black wire for ground and for positive. I said around 20 centimeters. It was about 17 or 18 centimeters when I was measuring it out before. We can just measure that as well. I've got a ruler to hand that we can just check. Our soldering iron, which I've got on screen, which is just I'll show you in a second. It's just a cheap soldering iron. I've not spent any again about 10 UK or US dollars for that to buy. So I haven't got one of the fancy thermostatically controlled ones, which I believe are a much better quality. Mine is just a cheap one, but it does the work. And we have some solder and some flux, which I just showed before. This is the thing that will help us make the solder stick better to the part. We have an Arduino. I've actually got an Arduino clone. I do recommend that if you buy at least one genuine Arduino to keep the Arduino people happy and keep them developing new products and so on. But you can buy these for about a tenth of the price, I would say. If it's about £30 to buy an Arduino, which is quite a lot of money if you think what a Raspberry Pi costs, which is about £5. These things are about £5-6 as well. And some filament. So like I said before, let me just change my lighting scene has changed. This always happens at dusk. So that means dusk is happening a bit later each week. Some filament as well for the tracks. That's one of the most common questions I've seen actually is where is the 3D printed part that's the joint between the tracks, and people don't realise it's just filament, you just need to snip. So that's what you need to build along. So the first thing we're going to do is clean up the parts. So this was me printing the part last week. Came off the bed. You can see there's a tiny bit of filament that was still stuck to the bed. So I did have to just give that a bit of a clean up just by removing the edges on there. It's still a little bit rough, I think. I also had some support structures which are inside there. They were like a little round structure that just helped provide some support. There's some parts within it there. It might just need to give that a once over actually. I can see there's still a bit. And what that is where the motor holders push the motors down into place. There's like a little slot, a little cutout. And on the original design that Kevin Thomas did, they're not at any kind of degree, so that it is just like an overhang like that. So the support structure just holds it up in place when you're printing it. So that's what we need to do, make sure any rough areas are sanded smooth to our satisfaction, and just to make sure that things work well. I did have to, like I said, with the wheels themselves, I've got a tiny little file. If I just go to full screen to show you what I mean. So I've got this wheel here, and I have this file, don't know who that's by, McAleer. And what I've done there is just sort of just made sure that this thing can poke through a little bit. You can just see in the end there, it's just sort of poking through. And for me, that seemed to work. That was the right amount of work required to be able to push this motor into place. So when it's actually on the Arduino, that's probably the right amount, and you've got plenty of grip, and it's still quite tough to pull off. He says, so that's the motors, the wheels, the chassis. And the other thing on the chassis as well is these stubs, the wheel stubs, the bottom of them where they print from the bed, sometimes that can be a little bit messy. On these, actually, it does look a little bit messy. If I show you that one there, it does look a tiny bit rough. However, the wheels work fine on it, so it's one of them, push it on, see if it works. If it needs a bit more work, get a file to it, smooth it out, cut away any pieces that you don't need. I think that's it. Yeah, the other thing as well, actually, just while we're on this, so inside here we have two, oops, doing this sort of in reverse, that little, where are we? There. That little stub thing there, and there's another one, oops, up there as well. Sort of doing this mirrored so it feels really weird. That thing there, these hold the motors in place, so when we get our motors and we push them into place, and we'll do this on the overhead cam in a second, that little stub just helps them sort of push into place, like so, and when the motor holder goes over the top of that, you get a really good solid placement of the motor. So sometimes they need a little bit of work just to make sure that the motor isn't sort of at a funny angle, that it is true to the base of the chassis. So that's the things we need to do for cleaning up. Just trying to think if there's anything else whilst I was printing this. I think that's it really. I did reprint a couple of parts from last week. So when I did my original print, I hadn't leveled my bed. So I had this part which was failed. So this is, you can see there, it's all sort of rounded. That wasn't good enough, so I reprinted that. So by way of comparison, if I do that, you can see the other one, this one is much better and much truer. And the other thing I reprinted was these, oops. these parts. So that was the motor holder. So I've done that. So the bottom one is the better one. You can see there the top one is sort of got a bit of a bend to it. That's because I've not leveled my bed. And the other part as well, I'm just looking around if I can see it there. That's just behind the leg of the tripod, was the rangefinder cover. So that's been printed in this sort of nice sparkly diamond stuff. It's come out really well. So yeah, what I did last Saturday, I didn't talk about this on last week's stream. So I leveled my bed, and I still wasn't getting the desired results. The BL Touch on my Ender 3, which is the little thing that goes down to sense where the bed is, that thing wasn't working properly. It kept glitching out, and I knew that this wasn't hardware, this was a software fault. So I decided I needed to flash my Ender Pro with the latest Marlin 2 firmware, and that basically took all of Saturday, just trying to figure out how to do this. I know it's quite straightforward, and probably people have done this billions of times before, but for me this was like really difficult to get working. It was as much the Mac. On the Mac OS, they're a bit funny about firmware drivers for when you plug in a USB cable to like an Arduino. It's the FTDI driver, I think. So in the end, I actually used a Raspberry Pi, the one that's running Octopi. I used that to flash the Ender Pro firmware. So yes, I'm gonna also. I've also bought for my 3D printer. Just goes out of shot for a second. 2 upgrades. So these are 2 new fans. Is it Noctua? So very fancy packaging. I think you're paying a lot of money just for the packaging on these things. So that's one of the little ones there. So that's a 10 by 40, and then this one's the 20 by 40, which is just slightly larger. You can see that's just in there. Going to focus a bit better. And it comes with a whole load of cables as well. And the point of that is it makes the Ender Pro, which is quite, the motors are very quiet, it's just the fan on the front that cools it. It's very, very noisy, so that's one of the upgrades that I'll be doing there. So let me go back to our slides. So we've cleaned up the parts, we're ready to go with them. And what we need to do is add the unpowered wheels to the chassis. So we're going to check the wheel stubs and the unpowered wheels, sure they no protruding parts and that they don't catch and that they spin properly. Can be a very tight fit. I got a little blister on my hand trying to get the things off because I put one on and it wasn't quite right and I knew I need to take it off. So one of the tools I have is some mole grips, and what I did was I essentially just got the mole grip to grab hold of the tyre, and then because it's, you know, this is quite a big thing, I could leverage it, and that gave me a bit more gripping power. So you've got some mole grips there, really useful to have as well in your toolkit. What else there? The repeating, for the other unpowered wheel. So one of the things I was going to talk about as a talking point, I was reading that Microsoft owned GitHub, and in GitHub for your source code control, the main branch is called Master, and from from next month they're going to rename that to be Main instead of Master, and it's part of the Black Lives Matters movement, and it's the software industry's way of sort of responding to this, saying that we want to get rid of any uninclusive language such as blacklists, whitelists, and the connotations that black is bad for a blacklist, white is good for a whitelist, and also for slave and master. Now I'm aware that when we talk about our robots, we talk about these being the slave wheels and these being the master wheels, and I thought, well, we need to do our part as well. So I've decided that throughout SMARS Fan, the website and also the material, we're going to refer to these as just powered and unpowered wheels. There's no real reason to use the slave and master terminology. So I don't know what you guys think about that, but I think that was an easy thing for us to do, and it's more inclusive as language. So, and it also supports and shows you our stance on the Black Lives Matter movement too. So I thought I'd just mention that too as a bit of a talking point. And that's why you can see I'm referring to these as unpowered wheels and powered wheels. So the first thing we need to do, let's go to, let's see, I'll go to full screen on here. It's probably easier to do it in front of camera this way. So these are the unpowered wheels. They've got the great big hole, it's like a donut. And this is the chassis part, and we're simply just going to push these into place like so. And this one's a bit of a tighter fit. Let's just push this boy onto there. There we go. And then it spins freely. So once you've done this, sometimes they're quite an easy fit like that one, sometimes they're a tighter fit like that one. It's important you give them a really good couple of spins, and that will make sure that any parts that protrude in, you know, the friction will wear them away. If you do it quite quickly, let's come off again, that's fine though, that they spin freer. Okay, so what we'll do next then, so we've done that for both of the wheels. We are then going to add the battery. So I've got my nice 9-volt battery here. This is just a standard alkaline 9-volt. You could get a rechargeable one if you wanted to be a bit more, I don't know if it's environmentally friendly, but it's a bit cheaper perhaps. I'm just going to try and find my 9-volt battery connector. I knew I had a bag of them. I've got a bag of all different SMARS parts. That's a bag of 9-volt connectors there. I've also got a box full of rangefinder faces as well, so loads of them. I always think they're the face of SMARS. There we go. So I've got my 9-volt standard connector. You buy a bag of these, it's pretty cheap. And I was always taught the way to test the 9-volt batteries, just stick the connectors on your tongue and see if you get a bit of a shock, and if you do, then it's got plenty of charge in it. So I've just plugged that into there, and that's literally just going to drop into place there. There we go. Just like so. So that's now sat in there. We've got our wheels, we've got our battery. It's just going to dangle out like that for now. Okay. Next we're going to cut some wire. How exciting. So, so what I'll do is I'll go over to the other screen, SMARS cam. There we go. Now let me just check you can still hear me on here. Let me just find my sound levels. Yes, you can still hear me now. That's good. What I will need to do is just move, sorry if it makes a bit of a clunk, but I just need to move my microphone over here so that I can work and also face the microphone at the same time too. So there's our little robot. So I've got some standard, say standard, it's pretty thin cable, but I think it's single strand, that's what it's called. So it just has one strand of wire going throughout it. Sometimes you can buy multiple strand, but these are single strand, and I've cut these to about 18 centimeters in length. That seems to be enough that when you put them in, you've got, you know, because it has to sort of double back to the motor shield board. So what I do, I've literally just cut this, I've not prepared it in any way. So what I would normally then do is I would cut away about 5 millimeters worth of white plastic coating from the end. So you can see there, if I hold that up, it's about 5 millimeters worth of wire from the end there. And this is single strand, so it's nice and easy to work with. So I would do that with all of them. I'm just going to do that quickly. Now you can buy some pliers that do this for you, but I just find if you just apply the right amount of force to the wire, it comes away quite easily. So there we go. And let's just do this other two. Right. And the last two. I'm just literally flicking these bits to pull across the room. I'm going to get in trouble for this later. Just wait till I've got my own studio. I can make as much mess as I like in there. Right, okay. So we've now got all the wires prepared. So what do we need to do next? Let's go back over to our Keynote video. So that one there. And so we've done that. So if these were not single strand, we would have to give them, I'm still here, we would have to give these a bit of a twist. And what that does is just keeps the strands together. But because this is single strand, we don't need to do that on these. So let's solder some motors. This is the bit that we're waiting for. So what I'm going to do first, let me get to my overhead SMARS cam. I'm going to get my flux it's a horrible sort of gooey pasty stuff. I don't know if you can see that there. It's like a yellowy colour. What I usually do is I just dip each of the ends of all of the cables into this, and what this will do is it will enable the solder to stick to it. So I'm just going to do that, and it just ensures like a really good connection. So that's that. We don't need to do that on the motors themselves. Now these motors, I don't know if you can see there, they have these tiny little terminals. You can just about see that there. And what we will do is we're going to, if you also look as well, I don't know if you can see this, see if I can get a good angle on that. Well, I'll tell you, you can't really see it, but there is a plus and there is a minus next to the terminals. Yeah, I might be able to just see that actually. I angle that correctly. So the top one there is the plus and the bottom one is the minus. So what I'm going to do is I'm going to push this cable through that little terminal there like that, and I'm just going to bend it so that half of the wire, so it's kind of like a little hook like that. So you can see that there. And that ensures that we've got a nice mechanical connection, so that when we solder it, if you were to tug the wire, it's not really going to tug just the solder off the wire, it's going to tug against that little bend that you've done. So I'm going to do the same there as well. So that's going to go into there and give it a bit of a twist. There we go, getting all the flux on my hands, lovely. There we go. So now that motor is has the wires connected on it there. So what I will do now, I've got some helping hands. I'd recommend you get some helping hands if you've not got them. And these are just like little crocodile clips. I don't know if you can see that there. It's like a little holder with a weight, and that just means I can hold it there whilst I do the soldering. So I've got my solder here. The soldering iron's been heating up now for a while. What I usually do as well with the soldering iron is just give the end a bit of a brush with, so there it is. So I just give that a bit of a clean up with a file. That means that the end's nice and sharp and there's not any debris or old solder or any kind of muck on the end. So what I will do, try and do this without moving the camera too much. This is why you need the helping hands. I'll also just dip that in the flux for a second. There we go. This is why you need the helping hands. You need to solder, you need to hold the solder itself, and I say, because I'm from the UK, I say solder with an L. I know in the US it's solder, so I say solder. So we need to apply the heat, we need to stick the solder in as well, and we need to have the wire sort of pointing in the right direction. So I'm going to try and do this, and I'll not be right near the microphone when I do it, so just bear with me. So I like to get a nice big blob of solder on the end of the soldering iron there, and then I'll just hold it on for a second, just enough that it runs between both the terminal and the wire. There we go, that's that one done. And let's do the red one now. So can we see this on camera? Just about. Okay, last one. There we go, that's done. That's one. Try and move the soldering iron about while I don't burn myself at the same time. There we go. Right, so that's that one done. Let's have a look at that a bit closer. I'll tell you what, I'll put it onto this. This one's got a better camera. I might be able to see this better, and the lighting's a bit better as well. So we can see there we go. Our mechanical connections meant that we've got a nice solid grip there. And the thing I then do, once I've done this soldering, is I will give these the wires a twist like this. And I do this for several reasons, so let's just give it a twist all the way to the end. like so. So then what we end up with is nice twisted wire like that. Now, the reason that I do this is if you ever tug this wire, you're actually tugging the force between both of the endpoints rather than just one. So it makes it a much stronger connection. And also, it will actually prevent... let's move this out of the way a bit. It prevents some interference as well. So if this was... I know there's not much data, it is raw power going to the ends, but by twisting wires around each other, you get less crosstalk. So that's the first one. Let's do the next one. So we're going to do the next motor there. So let me just find the plus and the minus. And we'll go to the overhead camera. I can see a couple of people on the chat. I'll say hello in a second. I'll just finish this dangerous soldering part first so I don't burn myself. Okay, let's go back over to here. Let's move my microphone over as well. Okay, so put the thing in the helping hands. So it's just grabbed it by the spindle. And then I'm going to use this end here. I mean, what I could do, it depends. Because this is a single strand, there's no real need for me to, you know, apply solder to the end of these and tin them. We could do that if it was a multiple strand to help bind the strands together, but we don't need to do that with a single stranded wire. So that is the negative one, that's the plus. So let's just shove the negative one through first. Do it that way. Yep, seem to have cut myself on something, who knows what I've done there. And then there's the positive one, that's going to go through. Exciting stuff this, isn't it? Exciting stuff. Okay, so now to solder. Oops. Just put the cap back on that flux, we don't need that again now. And there's our solder, here's our soldering iron. Let's do this. So maneuver that about a bit. Nice big blob of solder. And then for the positive, let's do the same. There we go. Okay, job done. So, the other thing I was going to say about soldering as well, you can see on the picture that we've got on screen at the moment, if I just move out of the way, let's just move me up there. This can that I've got down here that says McAleer on it, that is PCB cleaning fluid. I'm just trying to see where I put that actually. Right, so bear with me 1 second. Okay, I'm just going to unplug the soldering iron too. Don't need that to be on anymore. So yes, this, let's move out of the way. Sorry, I just thought I'd pressed the wrong button on my microphone for a second. So this is PCB cleaner. Let's just go full screen so you can see that. And what this does is it removes any flux, because flux will actually corrode the metal surface after a while. So it's great for cleaning the surface for it to solder to, but then you actually want to get rid of it once you've done that. So what I usually do is get this stuff. Now that I've turned my soldering iron off, I can do this. And let's go back to the overhead. Oops. Right one. And I just give that a bit of a blast on there. Blast on there. And then I use this tool just to clean up any residual stuff from there. See more on that one. Let's just brush off any residue of that. So we can see there we've got a nice connection. What we then need to do is just twist these wires again, and hopefully they'll be the same length. If not, we can just trim them How's that? That's not bad. So there we go. We've got another nice connection. So let's go back to our Keynote. So we've done that. We've dipped the ends in the flux. We've tinned the end if we needed to, if there were multiple strand, but these are single strands, so there was no need to do that. We threaded the wire through each terminal to give it a mechanical join, so that if it's pulled, it's pulling against the actual sort of eyelet of the terminal, the motor. We've done that 4 times, so we've got 4 cables now attached, 2 on each motor, and we've twisted the wires together again to give them extra strength. Okay, so now let's add them to the chassis. So let's do that full screen. There we go. So what we do now is we just pop this motor. Is going to go. So you can do this with the. So they do have kind of a, not an up and a down, but an orientation. You hear it click into place then. So if we now look there, that motor is now seated correctly. The spindle is poking out the side there. We then can do the same with the next one. It's just going to poke into there. There we go. And then what we then do next is get our little motor holders. These are these little white things, and then I push the cable through the center like so, so that the wire is now peeping out the middle, and that'll just help with our sort of cable management. And then what we then do is just push this down into place, and if we've done a good job on the cleaning and these parts are a good fit, they are a very tight fit as the design. There we go. And then I usually just use a tool, just going to use my clippers just to push this into place. Sometimes it can be a very tight fit. That's not quite gone in yet. Use something with a flat end. Just use this mole grip, that's got a nice big... There we go. So let me show you what that looks like now. So that one is now in place. So you can see it's flat, it's holding, if you hold it that way you can see that it's pushing down on the motor. Make sure that's really in place. Okay, and then we do the same with the other side. So we put the wire from the motor into the middle, like so. And we then push that home again. So let's do this on the SMARS cam. Might be easier to show you that way. So what I'm going to do is move these wires out of the way a little bit. Is just push down on that. Sometimes I bend it up with my index finger. It's a very tight fit on this particular model. And then let's push down, and then let's use something like that to just force it into place. There's a cat war going on there upstairs. A bit of a dog war going on upstairs, I think. There we go. That's a much better one. So you can see now both of them are in place. That one is particularly nice. It's nice and flat, and we can then, so you know a SMARS has got a front and a back. So the front has got this little lip on it, and that's where the Arduino pushes up against. So what I like to do is have the wires all going out the back. So I'll just bend them so that all the wires, there we go, are pointing down. There we go, and this is up. Okay. So back to Keynote. There we go. So we've added the wheels, we've pushed the powered wheels on into place. We're paying attention. Right, so that's what we need to do next. We need to get our regular wheel. Go back to hosts. This is our powered wheel. That's got the smaller hole in it. And we've got our little protruding spindle there. Now the spindles, I don't know if I can show this, I'll try and get a camera angle that shows you this. You can see there's a tiny flat bit. Maybe you can see that, maybe you can't. Let's see if I can get a good view on that. Maybe not. Right, well, you have to take my word for it. There is a flat orientation. The motor has is a sort of circle with a flat bit cut out, and these have also got a flat bit, so you need to make sure the orientation of these two is correct. So I think that one goes there. So I'm just going to push that into place. Now that's a good fit. We don't want to be protruding out too much, because when we put the caterpillar track on it, these two wheels need to be in alignment. So that one's a little bit wonky there, but that's the unpowered wheel. So these two need to be in alignment. Let's do the next one. So let's just get this piece there. Sorry, the microphone's right in the way there. There we go, let's try that. There we go. So we now have the wheels. You can hear the motor. Perfect. So there we go, nearly done. So add some tracks. Now I might have to do what we call in the UK a Blue Peter moment, where we say, here's one we prepared earlier. Anything that they were doing on screen in the show Blue Peter, which was like a kids TV program, anything that would take a long time to do, they would cut away and say, here's one we've already made, because this would take hours to do. We'll do a few of these just to show you what's involved. But what I'm going to do is I'm going to build the tracks that go around here. I'm going to fit them. So if I go to our SMARS cam there, let's grab my microphone again. You can hear me over here. Right, so I've got some filament, and what I'm going to do, I've got my clippers here as well. I'm going to get a piece of track, I'm going to get another piece of track, and then I'm going to stick the filament through the hole between all the pieces so that it comes out the other side. There we go. So you can see now that this track is being pushed through that filament there, and that creates our little join there. And then what I do is I'll cut this one off flush. So now that little piece of filament is now just stuck inside there, and you've got a nice little joint. So we have to do this a number of times. Let's just see how quickly we can do this. You end up just like poking yourself in the finger a few times with this, with a sharp bit of filament. Okay. And the filament we use is just the standard 1.75mm filament, so we don't use in the big stuff. And I think this is an ingenious part of this design, to use the filament to create a flexible track. You know, quite inspired, I think, from Kev Thomas to have designed this in this way, and to have figured out the maths to make the wheels so that the distance in such a way that, you know, 8 pieces of track is enough to make the caterpillar track work perfectly. So there we go, so that's 5, just need 3 more. Oops. Great. Let's try and do this as quickly as possible. And then we'll get to the chat and we can have a quick see what people are up to. Okay, you still see this on camera there? Yep, good. So what I do with the track is I'll keep these nice and flush so that there's no protruding pieces of filament sticking out. I've seen some people apply super glue to them. I've never found the need to do that. I don't know whether it's just the way that my 3D printer prints, that they're a very tight fit. When I've used the faster motors, sometimes they do need you know, that extra bit of security, but I've never used super glue myself. I have had track, you know, sort of explode on me. There's a little video put on Instagram a while back, and you could see there one of the tracks sort of explodes as the SMARS is just going too fast, and that's because the motors were like 300 RPM, I think. Right. So what I then do, once I've got, so I think that's 8 pieces. 8 pieces is enough to go around one wheel. So if you just wanted to, you know, do that and have it as a wheel covering, 8 pieces is enough for that. But we just need to do another 8. Let's just try and get 4, 5, 6, 7, 8. Let's try and do this as quickly as possible. I know it's not very interesting, but it's essential. We want to do the whole thing and have it so people can refer back to it. So I was looking to see online what other videos you know, people have created with SMARS, and there's some really great ones out there. Rather jealous of Bluino. He's one of our followers on this channel, and he's got like a very large number of followers, and he's built some pretty awesome SMARS as well. He's done some mods to it. One of the things I was looking at as well, I like to watch videos, you know, movies with robots in them. And there's a film from the, I think it's from 1980s, that's called Runaway with Tom Selleck, and I think Kirstie Alley's in it as well. That film is really ahead of its time. They had drones in there. They had personal assistant robots. There was one that was called Lois. This is a tough one to get through here. And Lois was like a domestic robot. She had one robot arm, and she was like a very blocky robot. And she would do things like cook food for them. But she had like a full-on personality, a bit like a home assistant we have nowadays, you know, Alexa or Google or Siri or something like that. And I was really impressed with this, but you look at it now and she looks so dated. It's like a hi-fi system from the 80s, like a really blocky rectangle, and she's just got this arm stuck on the side. It really doesn't look very good. Right, sorry, you can't really see what I'm doing here. I'm doing it too off camera. Right, so we've now got another 8 pieces there. So this should be enough now, once I've done this one, to do one side. So now I've got that, we're going to join these two 8s together in the usual kind of way. There we go. This one is a bit of a tight fit, so I'm just moving it round as well to try and ease it into place. And then what I do with the very last piece is I'll make it a much bigger join. So when I'm pushing this one through, and I'll do it in place, but I'll leave quite a big piece sticking out the side. And that's so that it makes it a lot easier if you need to remove them. So what I'm going to do now is I'm going to wrap, I'll do it starting from about there, wrap this round. Let's try and get it to go to the right place. Perfect fit. So let's get this last piece and let's push that through. There it is. So this can be tricky at times, but I've had a bit of practice. What I usually do, I've got a bit sticking out there, and I always stick it on that side, not on the other side. Stick it on the side that's facing outwards. So there we go. So now let's just give that a few rotations. It should spin quite easily like that, but although I can see, if I go back to the main screen, I can see that they are slightly leaning in, which means there's quite a bit of pressure there. But if we look that way, there's a bit of give. They're not too tight. I have got some others where it's quite slack. You want somewhere in between, but I can see that's ever so slightly pulling that way. I don't know if you can see that. Ever so slightly pulling up. And that might mean that if there isn't enough power, that it doesn't turn the motor. But we can probably do a little test. So we've got our 9-volt battery there. If we just connect two of these terminals together, a bit of a dog wall going on behind me. Right, if I get those together, let me just try this and see if it works. And then there's my red one. This is just going to spin the motor around. There we go. Yep, my dog really doesn't like this. There we go. So you can see it spinning nicely. So that's a good test. That's done well. I'm sorry, Minnie. You just see that's my Chihuahua there. And there's like a cat as well called Trixie. They like to have a bit of a fight. Usually means it's treat time. Right, so that's one side done. I won't bore you by doing the rest of them, but that's essentially how we do tracks. Now, if you find that the track is too tight, so when we did that little test there, and if it doesn't actually pull, if it's not got enough power to pull because it's too tight, what you might need to do is reprint a number of tracks. I'd print like another 4 pieces of track, but when you go into Cura, you can actually stretch it on one of the axes. So if this is the piece of track here, let's do it that way. This is a piece of track here. if you scale it in this orientation, is that the Y orientation, to make it a little bit, say 10% longer, you'll find that that gives it just enough play. And you don't need to do it on all of them, you just need to do it on maybe 2. And that's say print 4, because you might need to do it on both sides. But that will give it just enough play without it being obviously a lot longer than all the other pieces. And if you do have to do 2, put them on opposite sides of the track, say this side and this side, so that they're always in opposite sides of the track. So there we go. So that's that piece done. What else have we said? We'll leave one piece of filament longer, make it easier to remove. So we've done that. So we've got our piece that's stuck out there. I've kind of exaggerated this a little bit. I mean, you probably don't need to have it quite stuck out as much as that, but particularly I've got this tool here. I can poke the, poke that piece to be able to get it out the track, but you shouldn't really need to do that. But sometimes if if maybe you're going to change the motor out, you want to do some repairs on it or something, that might help. So, and then the rangefinder. So let's go back to SMARS cam. Those two are really making a lot of noise tonight. What are they doing? So yes, we want to get our rangefinder. So that's this piece. There's 3 pieces all together that make our rangefinder. So we've got our little sensor. What's that thing called again? It's a HCSR04. We've got our rangefinder holder and our rangefinder cover. So we get our rangefinder, and you can see there's 2 little tabs that we need to push it behind. And it can be quite a tight fit by design. And you want to eyeball it so that it's roughly halfway sticking out equally. Because when we push that into this rangefinder holder, like so, I'm going to push in like this, that is going to go into that little recessed area there. So it needs to be perfectly aligned for that. There we go. So it's a beautiful little face. The orientation as well, I think, is supposed to be that the triangle in the design of the triangle thing sort of is the point. It's pointing towards the actual wires. I think that's the preferred design. There we go. So we've got that little arrow design pointing at the rangefinder wires. And then all we do, we find the front, which is the bit that's got the extra tabs on there, and we slide this into place. Like so. So that's our rangefinder in place. And then all that remains to be done, we go back to our screen share, is adding the Arduino and motor shield. So we have our Arduino. So we just move our wires down out the way for a second, like that. Now you might find that this is quite a tight fit to begin with, or it might just go in perfectly like that. But essentially it's just going into those little slots in the side at the front. And then we get our motor shield, and that's just going to sit in the holes there. So it kind of goes flush to the front of the Arduino. So the very first pin should be the very first hole that way. And then on the back we've got our USB connector. There was a post from Rich this week as well, sort of saying that he's got an Arduino that has a micro USB connector rather than this very old-fashioned USB. Is it USB B or A? It's one of the very old connector styles anyway, like printers use, very big. And yeah, getting a cable that connects to that to USB-C, which is what I have on my Mac. That was interesting. So we're not going to wire this up, but next week we're going to take our battery wires, we're going to plug that into the motor shield. Should we do a bit of a preview what that's going to look like? So that goes into there. See, I need to screw them in. I've not got my screwdriver to hand, but if we do that and then that, I could see the Arduino flash into life then, and it's just doing its blink program. I don't know if you can see the white lights on there. You can just see an LED just in there, and there is a light flashing just inside. It's just got the blink program running. Yeah, you can just see it near my thumb. And there we go. That's with one track missing, because I know it's nearly 8 o'clock now. That is our pretty much completed Arduino build. So SMARS build. So let's go back to the to main screen now. So let's have a see if there's anything else we need to cover off on our screen share. So we've done the Arduino, that's in place now. We've added the motor shield. Yes, so next week, what we need parts-wise, if you continue in this build, you essentially need everything we built to date. You need the Arduino, you need the motor shield, you need the 3D printed parts that are assembled as we've done this week, with all the tracks as well. You need some DuPont connectors, and they're the things. I'm just looking around my desk to see if I had any to hand. In fact, this one has got some. So this little Arduino, I keep saying Arduino, this little SMARS has got some DuPont connectors. And what they are is these cables that have these kind of connectors on the end. They've got kind of a square connector on the end. They're a bit bent, the ones, and they enable us to plug things like Bluetooth modules, but also the rangefinder. That's going to go from the rangefinder, which is the male pin, to the Arduino motor shield, which is the female pin. So we need a male to female, and we need them to be about 10 centimeters in length. So if you need to buy some, that's kind of what you need, but they tend to sell them in packs, and you get male, male, female, female, male to female, in every color you can imagine as well. So that's what you need to get. You need a battery connector, a battery, a motor shield. So the things that we've covered off as well in this session 2. Okay, so that's the slides done. So let me go back to just looking at the slides there. That's the parts we need for next week. So just to see that on screen. Yeah, I think the only thing that I hadn't covered off in last week's to say for this week's was the filament itself. So I just had some spare filament that I think the actual spool had broken, and I thought, well, I can use that as just spare pieces there. Okay, so let's say hi to some people in the stream. I can see, not in focus there because my microphone's in the way. I bought one of these shock mics, they're called. It's like a little thing that keeps the microphone from when you bang the thing, it doesn't travel through to the microphone as much. So let's have a look on the chat. A few people have said hello. So Sammy joined early on. Hey Sammy, how you doing? Thanks for joining the stream. And Sammy also said it's a brilliant idea to adjust the terms, blacklist, whitelist, master slave. I'm glad you addressed it. Well, I think everybody can do their bit, and and I was thinking about how can I do something positive, to show solidarity with the Black Lives Matter movement. And then there it was, straight in the SMARS stuff. It talks about master and slave, and I thought, well, we can talk about powered and unpowered. That was quite an easy win for us, really. So I'm certainly going to go through the find and replace throughout the entire SMARS fan site, and from now on, that's how I'll refer to it too. So that was a comment from Samo. Sid says, good evening Sid, how are you doing? And Sveinborn says, hey, how you doing? How are you doing too? And you're just spinning up the wires, such a good idea. Yes, twisting them together. I think it does make them tidier as well, but it makes them easier to manage. So when they're on the on the back there, you can see it's just easier to grab hold of them, and you know that you're grabbing hold of just one pair of motor wires, because when they all come out there at the back of this thing, you don't know which one's which. So if there's 6 cables coming out, 2 for the battery, 2 for each motor, you might not know which is which. They're all just black and red. So this is my dog. She has this little bee toy. She's absolutely obsessed with it. Obsessed. She got it in her mouth there. I can just see it at the top of the stairs. Minnie, you might be able to see her. Minnie, come down. There she is. She's just got it in her mouth. She loves it. Come say hello, Minnie. Here she is. She's got a little bee toy. Loves that thing. She loves to do it when I'm on calls or at work and during live streams too. So as Feynman was saying, how long can the rangefinder see? So I believe it's about 50 centimeters, about half a meter. I think it can detect things very accurately up to about half a meter, right up to, to 0. In fact, I'll just say 0 because it does have to fire. So the mechanics of this is there's a sender and a receiver. So as long as it can send out a signal and the receiver can hear it, it can calculate the distance between the two. So it's probably up to about half a centimetre, so between 50 and half a centimetre. Some of them will say 3 metres. It also depends on the surface. So for this to work well, it loves really hard surfaces that are approximately the same height that it's firing out, because it's firing it, in that kind of axis. It's planar to the ground, to where the thing's being held. Now you might see some SMARS where they've actually got, I think one of the Bluino ones, he's got a servo, and it can sort of do that and check, and it can sweep round. So it can work out a few things, but you'd have to know exactly what angle this thing's working at. But I've seen kind of like a radar view where somebody's actually put it on like a ship radar, so that's quite cool. And Feinborn's also asking, is it just on off, or can it measure distance? It measures distance. So what happens if you look on the top of this motor shield, this little yellow section here has got 4 pins. It's got plus, let's try and get that shine out of the way there. It's got plus and ground on the very end, and then it's got R and T, and it's echo and trigger. So the echo sort of sends out a sound at a very specific ultrasonic frequency, and then so that's the echo, I believe, and then the trigger is like a microphone. It listens for that coming back off whichever surface, and it knows that the speed of sound is, insert speed of sound here, so it knows exactly how long it takes to receive that. So it counts how many milliseconds it takes to receive that same signal back. And then because of that, whatever the time difference between the two is, you divide that by the distance, by the speed of sound, you will get the distance. So it's like a very simple physics experiment. I remember being a student at school, and we went out to a playground, a football field, and we had to sort of clap like that and sort of walk backwards from our colleagues, our friends, and they could start to see we would clap like that, and then they'd hear the actual clap sound a couple of seconds later, and we had to get to the point where when we clapped it sounded like we were clapping, because we'd have to keep doing it like that every second. So they could actually see the distance, how far did you need to be away for it to be synchronized on the second again. And that's the standing wave that you get. So all very interesting stuff. So Sid says 2 centimeters to 400 centimeters. Thank you for the look up there. And I would say the 400 centimeters it's a bit iffy. You can, but it's very inaccurate. Once you get past about half a meter, they tend to be less and less accurate, and that's just down to the quality of the sensor. So there are other sensors that you can buy too. You can get like LiDAR. So I have one of the new iPad Pros, and that's got a LiDAR device on it, and that's actually like a laser beam that fires out, and it does the same. They call it time of flight. It figures out how long it takes for that to travel back, and that just uses the speed of light to figure that out too. So yeah, there's some pretty cool things in there. As Feinbaum was saying, there's some great potential, lots of obstacle avoidance stuff too. So yeah, you could do an awful lot with these. So some of the videos, if you go on SMARS Fan, I've collected a few of them in the video section. So you can do one where it'll detect something, stop, turn around and go to somewhere else. That's like an avoidance. You can do a follow one where it'll try and maintain the same distance. So if you move your hand that way, it'll try and keep 5 centimeters distance. If you do too near, it'll back off. So you could have, this is what Rich mentioned this in the community this week. Why don't we have some kind of like a swarm of them? And I was thinking if they all had, the follow mode on, we could have I've got 6 of these things now. We could have 6 of them all in a train sort of following each other. So I think I might be trying that this week. And Svimon says, that little one can measure 4 meters. 4 meters. Wow, that's impressive. Yep, it's quite impressive the things you can do with it. So there's obstacle, there's avoid, follow, and just generally sensing distances. So what I was looking forward to doing, and I didn't quite get it working right because I had the sensor too close to the motors. I had a little, is it here actually? I did have it on my desk earlier. I had the little sensor that can detect what orientation you are. So I did find out that you could basically work out if it was 90 degrees from where it started, in either direction. So you could very accurately say turn 90 degrees and then go off, rather than just sort of saying, turn the motors 3 turns or whatever, because you don't know how far a turn is in distance. So that was one of the things I was looking to do and make more accurate code with. So one of the things I do need to mention, half the people that watch this subscribe, and half of those that don't subscribe. So if you'd like to support me and my channel, I'm not asking for any cash or anything like that, or any Patreon, not yet anyway, please just like and subscribe and hit the little bell and set that to you know, the all, so you get notifications when we go live, and that can help get the channel numbers up. And you know, I'm looking forward to getting 1,000 subscribers. We're over 10% the way there yet, but I like seeing that number increase every week. It means we're putting content out there that people like and get value from. So if you've not liked and subscribed, if you're watching this on replay as well, please leave a comment in the normal YouTube comments. And you're missing out. You should be joining the live like all these guys. You know, we get to have a nice conversation and talk. So I get a lot out of this myself. I really enjoy doing this. So yes, one of the exciting things I want to show you this week too. Let me find my button for that, which is... I'm sure I put a button together for this. Maybe I didn't, but I've got... where is it gone? Studio. There we go. So hopefully you can still hear and see me on there. Let me just make sure sound levels... Yep, you can still see me. So this thing I've got here next to me. This is the design of my new studio. I'm on the wrong camera there. Let me just go back to that camera. That's better. So yes, this is my new studio design. So you can see the rugs there that we've got for some soundproofing. I've got 2 chairs there. I've got a little coffee table. I've got some Billy bookcases from IKEA, and the Ravraw, which is like a little wheeled table. I can put things on and move it around the room. This is where my chair's going to be. I'm going to have a table very similar to the table I'm on now, but I've got an iMac in front of me. I've got a 3D printer sort of off the screen. It's actually that way, but that's on the same thing as my iMac. And there's very little room, you know, all together there. I mean, I could actually show you if I just go to, oops, if I press the right button, SMARS cam, and I grab my camera off here. I move it over here, you can see what I can see. So I've got my main computer here, I've got the iMac just running the live feed. I can see how many people, we've got 6 people watching and so on. And there's my 3D printer with my drink on it at the moment. There's my microphone and my light. So at the moment it's very cramped, lots of mess there. There's a little SMARS robot there. It's got a little Raspberry Pi just running. Little Arduino sat in the background there. Lots of USB things plugged into a big hub there. Got my Stream Deck there so I can press buttons and change scenes. And we've got a table full of stuff as well that we were just looking at. So let's just put that back to me. I'll just put this back up here. Oops. There we go. So yes, my studio is going to enable me to do a lot better quality of content. So the lighting, you know, I can bring my dogs in still, but it'll be a purpose-built environment for doing live streams. Behind me I'll have, on this display that I've got on screen here, you know, this Billy and this Ragnarar thing. Ragnarar, what am I thinking of there? That thing will have lots of interesting things. I'm thinking like some movie posters, some SMARS obviously on display too. And I've got, you know, a much bigger working area. So things like the camera that I've got pointing straight down at the moment. I've just got a tripod, the gimbal that I use, the DJI gimbal. It's not ideal really. Yeah, it's a good camera, but it's not ideal for working with. So I'm going to do a better job of that as well. So we're going to have plenty of cameras. We can have a studio cam that you can see from a distance too. I've got plenty of GoPros for that. And there's a dedicated area for the 3D printer and all the filament too. So it's going to be really exciting. That I can't wait to get this. So it's currently in the sort of planning stages. We've got a builder coming next Saturday to dig up the lawn to lay some power cables down, and we also need to put some data cabling down as well because the Wi-Fi doesn't quite reach over there. So yes, who's done the thumbs down? How dare you? Somebody's done a thumbs down on the video. So what else we got on there? So we've covered off that. So yes, the comment of the week. So this week, let's just stop that music. There we go. Yes, so this week it's Tyron Dawson. So he said, what an awesome series. Can't wait to go through all these and build my first SMARS robot and first robot ever. Thanks for this. So thank you, Tyron, for giving me such good feedback. So if you want to be a commenter of the week, leave a comment below. Yeah, you can be commenter of the week and get mentioned on the video. So, and it's there forever. So just think what you can do. And all you need to do is just comment on the replay video. It doesn't work on the live chat, unfortunately. So Samuel was saying, I was thinking the same about the thumbs down. Haha. Maybe somebody hit the wrong one. That's what I think happened there. Maybe they just, they're so enthusiastic and they just pressed the wrong one. If there's something negative you want to say about the video, please let me know and we can certainly improve things. I'm open to all feedback. I might not necessarily agree with you and do it, but I'm open to all feedback. Cool. So let me just see if there's anything else I wanted to cover off on this, because there's a few things. So we've done that. So next week then we're going to be looking at the electronics. So should we just go back to that slide that showed what we need for next week? So we need the need to show that on screen as well. There we go. So what we need is the assembled robot to date that we've been building along. So if you've not got to that stage yet, please just go and let me just move me down into the corner there. Yes, so where are we up to? So I just need to make sure I can see my sound levels. There we go. Yes, so you need the robot. If you haven't built the robot and you can see all the videos that we've done to date, you can catch up with that. Or if you just want to watch for entertainment value, that's what this is here for too. So you need that. You need the rangefinder module, because we're going to wire that up as well. We need some DuPont connectors, which we talked about earlier. They're the little square things that plug into the top of the rangefinder and into the top of the motor shield. We're going to wire that up. And we need some a battery and a battery connector to give it some power. And if you haven't got a motor shield already, I like these Arduino ones. These are my favourite style of motor shield. They're quite cheap, but they've got a lot of things. You've got a little buzzer there, so we can make it play tunes and things. And we also have dedicated like pin headers, like this little yellow one here for the rangefinder, so it makes it really easy to plug it in. And they just wire through to a standard pin on the Arduino. That's all it's doing, it's just shortcutting it to there. And they're pretty robust as well. They also have things like there's like a black, white and orange pin thing as well. And I think they're for servos. So yeah, it makes it very easy to expand what we do there. So yes, we're going to look at electronics and just wiring everything up next week, and then we're going to look at the code a week after that, loading the code into it. Might try some other people's code. So if you've got some code you'd like us to try, maybe we'll do some measurement as distances and things like that too. And we've worked on some of the other series we did. We did one on the Arduino and coding that. So we'll probably take some of the code that we've already written for that too. So if there's no more comments from anybody, what we'll probably do then is speak to you next time. And, you'll have to keep building these robots, bringing them to life with code and having a whole load of fun along the way too. So thanks everybody for watching along. I shall see you next time.